In this chapter, we'll talk about this thing called hypothesis testing and what it is. We'll start off by introducing hypothesis through a court case scenario. And so let's start here. Let's look at a scenario and let's say that a bank robbery has just occurred. Cops have apprehended a suspect that seems to match the description of the person committing the crime. And here are the details. So you have a suspect, 5'10", getaway vehicle was a yellow Corvette, and the person had on a baby blue tuxedo T-shirt. You know, one of the ones that say "party" in the front, business in the back. I don't really think it says business back. Then it's a mullet. That's okay. So let's talk about how this is going to involve hypothesis testing. So what we're going to do is we're going to develop these things called a hypothesis. We're going to develop it based off of a person going to court. And here's what happens. When you go to court, the first thing they tell you is that you are innocent until proven guilty, which is one of the reasons why when you hire a lawyer, the first thing they tell you to do is shut up and don't talk. Your innocence never has to be proven. So, and I know this kind of counterintuitive to what you see today, and people normally when they get accused of something, they're normally trying to prove that they're innocent. No, court has originally set up the hypothesis, is what we're going to call this now, the assumed truth. And we call the assumed truth this thing HO. It calls HO, and it's the assumed truth. And in court is that you're innocent. It's what we're going to assume. And when we do a statistical test, we have these things called hypothesis test. When you do these statistical tests, you have to start off with a null hypothesis. What is the assumed truth or the assumed claim that is made? And we always write it as HO equal to something. And we're always going to test around the parameter for now. Our parameter will be mu, which is the true population mean. So every problem we're going to do is going to involve the population mean. So we're going to have a parameter. And so we're going to say HO mu equals something. So it should be written like HO mu is equal to. And in terms of a court case, that means that mu is equal to you're innocent. That's the assumed truth. And now when you go to court, you always have this claim that is going to compete with the null claim or with the null hypothesis. And we call it our alternative hypothesis. So this is what you're competing with, and this is what we have to show evidence in favor of. In order for this to be true, you have to show evidence for it. So for this particular thing, for this particular hypothesis, we call it HA. And for HA, you must show evidence. You must show evidence in favor of it. And so when you go to court, the competing claim, if you're innocent, your competing claim is that you're not innocent. We always want to write that "not" as like a compliment type of thing, but not innocent also means that you are guilty. So if you're not innocent, you're going to be guilty here. But we write it as mu not innocent. So what it really means is that we say mu equals innocent. This should be mu is, and we write it like this. Let's write this as HA mu does not equal innocent. So we write it like that. And there's 3 different directions of statistical tests that you can test. So we're going to assume the truth. We're going to assume that the mu value they give us sits at the center of the curve. And then we're going to bring evidence on a belief that we have. That's going to put it either on the right-hand side of the curve, the left-hand side of the curve, or if we really don't know what side of the curve, we just know it's not in the middle of the curve anymore. Let's put it on both sides of the curve. And so we have 3 different tests that we can test these alternatives at. And the first is called the left tail test. And the left tail test, here's what happens. You have your mu here, but you discover evidence that brings it to this side of things. So you're testing over here. So if mu falls out here, it's what we call the safe region. If mu falls out here, it's what we call the rejection region. Likewise, in a right tail test, again, your mu is sitting at the middle of the curve. And this time, you're on the right-hand side, so something greater than. You find mu values that are greater than. So again, this part is the safe region. And this part is going to be your rejection region, where you're rejecting it at. And then in a two-tailed test, you don't actually know what side of the curve you're sitting on. You just know it's not at the middle of the curve anymore. So mu is here, but you're rejecting either on the right, on the left, or the right-hand side. And so here, you have this, and you have this. And so now your rejection regions fall here. Here you can reject, or here you can reject. But notice these symbols that you have for each one. When it's on the left-hand side, that's a less than tail. That's a less than or left tail test. And you use this less than symbol. On the right-hand side, that's a greater than or right tail test. And you use this symbol. If you don't know what side it is, that's a no direction test or a two-tailed test. And it's not equal to. And so here are examples of how we write an actual hypothesis. So this is going to start our test. We're going to write a hypothesis. And here's how it works. First example says, a school publicizes that the average number of children in the class is 25. Parents of a PTO believe that that claim is more. What is the hypothesis to be tested? So the first thing you want to do is you want to identify what is the parameter of interest. And again, our parameters are mean. Well, what are we talking about here? Let's underline the parameter. And the parameter is the average number of children in a class. This is our mu. This is what mu equals. So we're going to write this as, the null is what the school publicizes. We have no reason not to believe that what they're saying is true. So we're going to start off by saying mu is equal to, null is always equal to, and this HO is equal to, or mu is equal to 25. The alternative now is based off of evidence that we have. And we believe that going around looking at classes, we believe that we've seen more than 25 in the class. So we're going to write this as HA, the alternative. Parents of a PTO believe that it is more. That's a right-tailed test. So right now, here's what you're thinking. The mean is, or here's what they tell you, the mean is at 25. You think that it's more, somewhere over here. You don't know what that value is, but you just think it's more in that region right there. So we'll just say that HA is, mu is greater than 25. And again, remember, what does mu stand for? Mu stands for the average number of children in the class is 25. So this first one says the average number of children in the class is 25. This one says the average number of children in the class is greater than 25. Okay, the next one. The car dealership announces that the mean time for an oil change is 15 minutes. A group of consumers believe it is different from the time being advertised. What is the hypothesis to be tested? So again, identify the mean. So our mean here is that a car dealership announced that the mean time for an oil change. So, well, what did they announce? They announced that that mean is equal to 15 minutes. HA, the alternative is that, well, what are we testing? A group of consumers believe that it's different. What do they tell us? How it's different? Is it more than? Is it less than? They don't tell us. So we'll say that mu, since they don't tell us the directions, a two-tailed test. Here's what you have right now. You have this value at 15. They didn't tell us it was more than, because it could fall out here. They didn't tell us it was less than, it could fall out here for the rejection region. So we'll just say that this is not equal to 15. We don't know the direction. It's a two-tailed test. The last one says, a company advertised that the average life of its furnaces is 18 years. An advertising group believes that it is less. What is the hypothesis to be tested? So again, the parameter is here. That's mu. So it means that HO is mu is equal to 18. And HA, well, this time they tell us that it's less. So that's a left-tailed test. And so what that means is sitting out here, they haven't established 18. We think that it falls somewhere out here. So that means that HA is mu is less than 18. Now notice that in hypothesis writings, when you write a hypothesis, whatever mu is here, whatever this number is for the equal part, it did not change. It will never change. It will always be the same. The only thing that's going to change is going to be the symbols in between there. And this first one is always equal to, and this was always going to take on either a direction or no direction.